Oh, hey there. It's Jeff at the Nurture Nature Center, and this is Science at Home. Now, I don't know about this guy, but I'm a really big fan of Halloween. We all are here at the Nurture Nature Center, and that's why this week's video is all about trick-or-treating. We're going to be talking about the science behind the tricks that you'll see in a mad scientist's lab. I'll be borrowing some equipment from him, and we'll be talking about the science of treats, the science behind some of your favorite candies. So with that, let's get started. Exit stage left. No. Your other one. Sorry about that. So here we see a typical assortment of equipment that you might see in a mad scientist's lab. What are these things for? High voltage machines, bubbling liquids, lasers. I don't know what the scientists are doing with them in the movies, but I can tell you how some of these things work. The most popular pieces of high voltage equipment in horror movies has been the Jacob's Ladder, which features two electrodes that look like bunny ears and a spark that passes between the gap between these two, and that spark tends to travel. It tends to start near the bottom and move upwards. And these kinds of high voltage gadgets are featured, again, in some of the most famous science fiction and horror movies of all time, including the 1931 Universal Studios adaptation of Frankenstein. This Jacob's Ladder is powered by two 6-volt batteries, which together produce 12 volts of electricity, and that 12 volts of electricity is connected to a transformer. This is called a buzz transformer, and basically inside this transformer there is a coil of wire that is in close proximity to another coil of wire with more turns on it. And that's how this generates the extremely high voltages that travel up the antennas. I'm going to turn this on now, but I just want to remind everyone to never play with high voltage equipment. It can be extremely dangerous. So here you can see that blue spark of electricity, and it is jumping the gap between the electrodes. Another common movie trope, at least in mad science labs, is racks and racks of colorful bubbling liquids. Maybe this one here contains the potion that turns Dr. Jekyll into Mr. Hyde. Who knows? What are these things filled with? How do they make them bubble like this? Well, the answer is very simple. These are just glasses of water that I added food coloring to, and I've dropped in pieces of dry ice, or frozen carbon dioxide. Dry ice is a solid block of frozen carbon dioxide, but as it melts, it turns directly into a gas. That's what these bubbles are. These are gas bubbles of pure carbon dioxide. That's why it's called dry ice. It goes from a solid directly to a gas without becoming a liquid. Unlike, say, water ice, which when it's frozen, it's a solid, and then if you raise its temperature, it turns into a liquid, and then if you raise its temperature even more, it turns into a gas. This is called a phase change. Dry ice is extremely cold. It is around minus 109 degrees. These extreme cold temperatures make dry ice dangerous. You shouldn't touch it directly. At these temperatures, it can actually cause frostbite very quickly. It can freeze tissue, so never handle dry ice directly. Oh no, I seem to have rested my hand on this block of dry ice. Oh dear. No, but seriously, make sure that if you're ever going to handle dry ice, to use protection of some kind, a barrier, like a glove. So you'll notice some fog being produced by the dry ice in the glass, and by this block of dry ice even that's not sitting in glass. This fog is not actually frozen carbon dioxide, or even carbon dioxide vapor. It's water vapor. The water in the air is cooling off and turning into a vapor, into a kind of fog. And this is why dry ice is often used in movies to create bubbling, foggy-looking liquids, and if you have a large enough block of it, you can actually turn a whole stage into a nice, creepy-looking, foggy environment. Let's see how much fog we can make. Whoa! Looks like a witch's brew. Double, double, toil and trouble. Fire burn and cauldron bubble. So let's keep that dry ice around for a little bit longer because we need it to see our final staple of a mad science lab, and that's lasers. I have here a laser pointer, and you can see the beam because the fog passing through the beam is scattering the light, and so we can actually see the beam of laser light. Now, one cool thing you can do with lasers, or really any light, is pass the light through a prism, like this. If you pass white light through a prism, the light is split into a rainbow pattern. But if you just take a prism like this one and put it near a laser, it will actually deflect the beam. So now the beam is changed direction, and it's now pointed this way. And if I put in another prism, I can change the beam's direction again. So now the beam it started over here, going that way, and then it bounced through our prism and through our second prism, and we actually send it back from where it came. Let's do one more experiment with that laser. I've set it up so that the beam is shining over here onto this target. You can see that circle right there, which is produced by the laser. And you can see it is close to a perfect circle. Let's just fill it in. I'm going to use a marker to fill in where that circle is. So that little circle represents our beam of laser light. And I'm going to now change the laser by taping this hair over the front of it. I'm going to just put the hair directly in the path of the laser light so that it blocks a little bit of the laser light. So that's how the laser light started, and maybe you think that after I've put the hair in front of it, the beam will look like this. Let's do the experiment and see what it actually looks like. So here's what it actually looks like, and it's probably very different from what you were expecting. Instead of a circle with a line through it, we see a circle with no line in the center, and going up and down from that center circle are a series of dimmer and dimmer circles going in both directions with little gaps between them. Now, I'm not going to tell you why this has occurred. Instead, I encourage you to look it up yourself, find out why putting a small gap over our laser light would create this kind of pattern, and if you find the answer, go ahead and post it in the comments section. So let's talk a little bit about treats now. There are all kinds of wonderful candies that you're likely to encounter on Halloween, but some of my favorites are the layered candy bars that are so popular. And there's a really neat at-home activity that you can do. This comes from NASA, actually, and we'll include a link in the video. But it's an activity where you actually learn about geology by studying, of all things, the layers in candy bars. I have 4 different candy bars here, and they've been cut in half so that we can see inside of them and see the layers inside of them. And they each exhibit different properties that you'll actually find within rocks in the Earth, or on Mars, or on the Moon, for that matter. So, for example, this first candy bar, you'll notice that it's very shiny. Its surface layer is very shiny, and this is similar to a feature that geologists refer to as luster. And as we go down lower, we find this very crumbly layer. In a rock sample, this would be an example of a rock that's friable. It fractures very easily. These different layers make this second candy bar heterogeneous. It has different, very distinct sections that are different from one another. If we look at our third candy bar, this one has a feature known as cleavage, and that means that it can be split into flat segments. So we can split it apart and pull it apart. And you also notice these big lumps right here. Now these are peanuts, but in a rock sample, we might refer to these as inclusions, or different impurities that we find within our rock sample. Alright, I hope you enjoyed that at-home activity. Just make sure to be very careful while cutting the candy bars, because you do not want to have an accident, like I did. It's okay, though. I actually have complete control over my legs. From everybody here at the Nurture Nature Center, I would like to wish you a happy Halloween, and I'll catch you next time. Bye.